Thank you, Saulius. It's my pleasure to meet all of you today and present principles ranking of water supply and sewage networks, assess the latest data on the actual condition of the objects. Briefly about myself, I have been working in Vilniaus vandenys for 15 years already, and now I'm heading infrastructure planning and technical strategy unit. Vilniaus vandenys is the largest water supply company in Lithuania. We operate water supply and wastewater networks in capital city Vilnius, as well as neighboring regions. Company shareholders are 4 municipalities. Now, company numbers. We serve about 300,000 customers and operate 1,600 kilometers of water pipelines. For comparison and imagination, this distance is a bit longer than the one between Vilnius and Amsterdam. Our daily water supply is 90,000 cubic meters that are extracted from 295 deep wells. We operate 36 well fields, 20 drinking water treatment plants, 153 drinking water pumping stations, and 45 water reserves. Moving on to wastewater management, we operate 1,300 kilometers of wastewater pipelines. Daily collection and treatment of wastewater is around 115,000 cubic meters. We use 186 wastewater pumping stations to collect and transport the wastewater to 7 wastewater treatment plants. Infrastructure investment objects are planning by 4 methodologies. In 2020, the company has approved the methodology for ranking of water supply, wastewater networks, and station reconstruction objects, which is designed to identify priority objects of wastewater and water supply network reconstruction, taking into account objectively assessed condition and importance of objects. The main focus of today's presentation will be about methodology for ranking of network reconstruction. The purpose of ranking methodology is to determine the priority of objects for reconstruction of Vilniaus vandenys water supply and sewage networks objects, assess the latest data on the actual condition of the objects. The ranking of reconstruction objects is performed every year, evaluating the latest data on the actual condition of the objects. According to the total value of the scores, the objects are sorted in the ranking order, from highest to lowest. The ranking of reconstruction objects in the initial stage is performed according to the technical parameters of the objects. The methodology ranks the groups of the objects to be reconstructed or renovated according to 2 categories: the condition of the objects and the importance of the objects. Each category is assigned a corresponding ranked attribute with a group of selection criteria. Each criterion is subject to a selection scoring system from 0 to 5 points, where 0 points are obtained when the criterion is irrelevant, 1 point the least critical, 5 points the most critical. A selection scoring system is applied to each criterion according to the relevant characteristics. The criteria have different effects on the need to include the objects in the investment list. Therefore, they are assigned weights by which they influence the final evaluation score. In this methodology, we are ranking 2 groups of reconstructed or renovated objects: water supply networks and sewage networks. These 2 groups are divided into network type. Water supply network is divided into main network, distribution network, and inlets. If you don't have information about water supply network type in GIS, we use network diameter, and the system converts the diameter value and assigns a type. Sewage network is divided into pressure, gravitation sewage networks, and sewage collectors. Water supply and sewage network ranking attributes such as network type, position, diameter, commissioning, via system taken from GIS. If we don't have these attributes in the GIS, the system collects information from financial accounting program Stekas. Number of faults and accidents are taken from geodispatch. Possible extent of accident damage, network condition, and TV diagnostic conclusion are taken from new GIS board application. In our GIS database was created 2 new networks layer boards, condition of property, in which networks are connected by global ID. This allowed us to have more network status values. In our GIS portal was created internet application in which our field workers enter the data of a network status. Application was created by using standards functionalities. With the help of Smart Editor widget, we can edit the data in the network's layer board's condition of property. In this example, you can see how it looks the ranked object data entry of possible extent damage with the help of Smart Editor, the field workers' data entry after the inspection works. They choose the meter and monitoring value. Then save the data in application. The water supply networks are marked in bold blue and the status of a network changes accordingly, marked in red as an example. The same as water supply networks, you can see the ranking sewage networks, which was entered by employee. According to the type or ranked network object and the corresponding available attributes, calculated the score of each individual attribute. The scores obtained are adjusted according weight. In this way, obtained the overall ranking score of water supply and sewage network in the BI system. With the help of this methodology, our company more efficiently selects faulty networks and allocation of funds. Also, we avoided a human error, and in one system we can find all information about the states of the networks. What's next? We are not going to stop. We are planning to prepare new methodologies for ranking of energy installation and wastewater treatment plants. Visualize networks in GNS by critical score. Collect more detailed data about the network and analyze it more detail. Collect more data about managed networks as well as operational tasks by migrating GIS to the ArcGIS utility network. Thank you very much.